All right, let's jump right into our explainer on absolute value functions. It's a foundational math concept.
So let's kick things off. What exactly is absolute value anyway?
Simply put, it's just a number's physical distance from zero on the number line.
Because distance is always positive or zero, both 10 and negative 10 are exactly 10 units away.
So the absolute value of 10 and negative 10 both equal exactly 10.
Now, if you come across the equation absolute value of x equals 10,
It's basically asking for all values 10 units from zero, meaning x is 10 or negative 10.
We can actually define this exact behavior mathematically using a piecewise function.
This shows that when x is 0 or positive, the absolute value is simply x.
but if x is negative, the absolute value flips to the opposite of x, making it positive.
Okay, why does this matter? Let's apply this to a real-world scenario.
Imagine you pass a test if your score is within 20 points of an 80. We'll let t represent that final test score.
The literal distance between t and 80 can't be more than 20 points.
This absolute value inequality perfectly captures that exact physical boundary for passing.
So how do we actually navigate these different absolute value inequalities?
Well, if the absolute value of x is greater than a non-negative number a,
then x is strictly more than a units away from zero on the number line.
Crucially, greater than inequalities produce an OR statement, pushing outwards away from zero.
Conversely, if the absolute value of x is less than a,
It just means x is less than a units away from zero.
this produces an AND statement. Basically, x is trapped between negative a and positive a.
Check out this table. Greater than means an OR statement, and less than means an AND statement.
So think about this. How might absolute value define the physical boundaries of the room you're sitting in?